All right, on page 3, we looked at analyzing sequential systems. What that meant was looking at a circuit like this and then coming up with a state diagram that describes how it behaves. It's almost like reverse engineering. You look at the circuit and figure out what it does. So that's analysis of a sequential system. On page 4, which we'll focus on in this video, we're going to look at the designing of a sequential system. In this case, instead of starting with the circuit and then ending up with a diagram, we do just the opposite. We have a state diagram that describes a circuit that we want to build, and then we have to design it, figure out what flip-flops and what logic gates we'll need to achieve this state diagram. This figure is figure 7.1 from your textbook, and you're going to be using JK flip-flops, a 1 Hz clock, a switch for input X, and LEDs to monitor the states, or the state rather. Q1 and Q2 are going to be used to record the state, and Z is our output right there. It's first asking you if this is a Mealy or Moore model circuit, and the way you do that is you look at this diagram and then compare it to the examples we showed in the PowerPoint slides. So what we'll see in this one right here is that 6.22 shows us a Moore diagram, and you can see that Z depends upon only on the current state, whereas over here in the Mealy model, the lower right hand side is where the Z is. It depends also upon the value of X, in addition to the state that the circuit is in. What they're asking you to do next in step 2 is to sketch the state diagram, this thing right here, but instead of using A, B, C, and D to represent the states, they want you to use Q1 and Q2. This is going to be corresponding to flip-flop 1 and flip-flop 2. Notice here they're going to lowercase letters. And this is going to be state 0, state 1, state 2, and state 3 for these letters A, B, C, and D. Now I've already gone into my image processor and replaced everywhere where it said A, B, C, and D with those corresponding numbers that you see here. So this might help you visualize it, and it's certainly going to help you test your circuit, because now we see the values of Q1 and Q2 in the state, and we can see that as displayed on 2 LEDs for Q1 and Q2, and the output Z, which is here in the circle. So that helps you visualize the circuit. Then it says construct the circuit and verify that it works properly. It gives you a hint of looking at the equations on page 422. So this is a design of sequential system, and there's several steps involved. But what we're going to do is do those steps in class. But in lab, I just want you to look through the solution to this circuit in your textbook, and you'll see that it ends up giving you these equations on page 422. So they walk you through how you go from a state diagram to an equation that would lead to a circuit. So what you can do is down here for the circuit sketch is you can have 1 square for for flip-flop 1, 1 square for flip-flop 2. Make sure you put your X over here and your Z over here. Tie a clock in there as well. And then what you can do is use these equations to figure out what logic gates need to be fed into J1 and J2, K1 and K2, and what output Z should go to. So that makes this page go a little bit simpler because they've already worked out the solution for you in the textbook. I want you to go through that process of see how they got to do it. And in class, we'll spend some more time on figuring out how you go from a state diagram to a circuit that performs that task.